Adriana, and I go to Olathe High School, and I did aerospace engineering at the LASP, which is Laboratory for Atmospheric and Space Physics. So, yeah, what I did was the engineering at that lab, and I worked on a 3D printer. I also worked on this thing called the MEMS project, and I worked with SolidWorks to build a testing stand for the people there. So what the MEMS project is, it's basically a very tiny little mirror, and it's basically nanotechnology, which will be used to put into telescopes, which then they send the telescopes out to space, and then from there the telescope takes pictures. And what this does, well, it will actually get better detailed pictures, and it will just get better pictures. So this is what the actual mirror looks like. Right in the center of where that green dot is, it's actually a laser pointing at the mirror right now. And so with that, the laser reflects off the mirror, and then it hits a grid or a poster board with a grid on it, and that's how we did our testing. We had to do it on a microscopic level and then a macroscopic level. So for the first testings was like pointing the laser at a grid on a poster board, and we basically just tilted the mirror tilted it back to see if there was any difference in the accuracy, the pointing accuracy. And so we had to do it in just regular condition, like without any heat applied to it. And then once we did those, we also had to do thermal heating. So we would set a heat lamp directly, well, not directly, but pointed at the mirror to see if the mirror would in any way warp the way the laser was pointing. And so the way we would test for the microscopic level is that we would send the laser pointing at the mirror, and then the laser would point back into a CCD camera, which is the regular type of camera that you would find in surveillance cameras, actually. And what I learned from this is how to use this application called SharpCap, and I also learned some coding from that. So on the left side is what the actual application looks like. It's very, very fuzzy, but that's what the camera is picking up. And then this was just the general setup of how everything was. So we had the computer, and then the laser right in the middle, and then the mirror over here, and then all the way in the back was the camera. And then that was just the undergraduate that I was working with. So it was actually a really convenient time that I started my internship, because she had actually broken her arm skateboarding, so I was just kind of there to help her move stuff around, but she was really cool. So, yeah. And then what I had to do next was work on a 3D printer. So it was the Modex model, and what it's going to be useful for them over there is to print out little models of any like satellites or other spacecrafts that they're going to try and just see if it will actually work. So I worked with Dimitri. Dimitri was my main mentor who I was working with. And actually, when I first started working on this, and then I also transitioned it over to Cutler, which is also another Pintern. So yeah, Cutler. We'll hear more about his presentations. Next. So here's me and Cutler on that side. At one point we were left alone to work on the printer, but that was still a cool thing because it kind of just left us to figure out things on our own, which I enjoyed because it helps. It's a learning experience. And then here's just like all of this was assembled. So none of that was pre-assembled. We just had to put all that together. That's actually just a corner of the printer. So there's Dimitri in the middle. For reference, he's like this tall. So the printer is pretty big, yeah. And that's the finished project. Next. So the next thing I had to work on was testing sand. So I had to work with the team, it's called, I actually forgot what stands for. There's a lot of like abbreviations that I don't remember, but I do remember that this satellite piece was called CUTE, which is Colorado Ultraviolet Transit Experiment. It is a NASA-funded project, so it's pretty expensive. But it is just the size of like a tiny toaster oven. It's just a satellite. What they're gonna do is they're gonna see the radiation from supernovas and where they went. And basically the satellite is just gonna show us how our universe came to be, and then to see where it's gonna be going next. But I had a very small part in doing anything. I just made the testing stand for this, and I just used SolidWorks for this. So yes, that's actually a very small portion of what I was working on. I just had to build a testing stand for just the pink piece right there. So basically that tiny little red wire is a wire that will be heated up. It's the same wire that you would find in an actual toaster oven or in a hair dryer. They heat that up, and then the weird middle two pieces, the white two pieces, is actually just a rope. And so basically the wire will heat up the rope, burn it, and then it opens up the satellite like a book. So here I just had to do the testing plate, and I worked with Dana. She's a graduate student, but she's a mechanical engineer. And so here is like both of us just drafting up what I was actually gonna build. And then here's where I actually got to actually start building the whole thing. But unfortunately, my internship was already at its end, so I have not been able to see the finished product of it. Neither has Dimitri, because he did have a kid. So he was like out for 2 weeks, or no, he actually told me 3 weeks. So we both don't know how it's going at the lab right now. But we're hoping that, well, I'm hoping that my model that I gave to them is good enough, you know. But yeah. In my free time, I got to hang out with Emery too. I dormed with her. She's also another Pintern. And then for the 4th of July, I actually got to go to a Rockies game with Dimitri and his friends and his wife there too. And then I also just spent my days walking over to the park and just drawing. And then, yeah, just walking around and hiking. It was pretty big city, so there's LASP. Yeah.